Hi students, so in this video I'm going to go over this enrichment problem that I had posted yesterday, April 28th, 2020, and the goal of this problem is to find out what side lengths A, B, and C are, okay? And the setup of the problem is we have one big right triangle with an altitude drawn from the vertex of where the right angle is down to the hypotenuse. And that too is drawn, being that it's an altitude, it's going to form a right angle with the hypotenuse there. So the goal again is to find out what those highlighted lengths are. Let's take a look, okay? At first sight, okay, you should be able to recognize that this setup, okay, it's a classic regions example. I would say that it's also a classic SAT question, okay, where it's asking for your understanding of this concept, which is called a geometric mean. So, having gone through the various Khan Academy assignments and videos, okay, you should be able to recognize that the geometric mean, or the formula related to geometric mean, goes like this. So if you have this setup, okay, where I know this side here is, let's say, m, this side here is n, and this side here is p, then these three sides, okay, share the following relationship, that if I multiply m, side length m, and n together, I will end up with this being p squared, okay? And we refer to this number right here, the p squared, as the geometric mean between side lengths m and n, okay? So this is the formula that you will need to use as an initial step, okay? If you want to see why or how this formula came about, I can certainly create another video on that, okay? But you've viewed the Khan Academy assignments and have gone through those assignments, and you should be able to recognize this formula here. So I'm going to place that right there. All right, so now having this understanding, okay, I can see here that I have side length A, which I don't know. I don't know this side length over here. I have no idea of what that side length is. This side length here. I have no idea what the side length is. So rather than creating another unknown, what I will do is try to express that left side using letter A. Okay, so if I know the overall length of the hypotenuse is 15, I then should be able to declare that this is 15 minus A. And this length right here must be A. If I were to add 15 minus A and A together, I will end up with 15. So, I really didn't do anything that special. However, I am expressing one side length in terms of another. And being that my end goal is to figure out what A is, okay, I can now apply the concept of the geometric mean. So looking at this, I can take 15 minus A, which is like my side M here, and multiply it by side length A, which is like my side length N there, and equate this to side length 6 squared, which is like the side length P, which is in that formula. So I now have an equation with an unknown. I now have enough to go with to figure out what A is. So what I'm going to do is I'm going to FOIL this out. So I have 15, not FOIL, distribute. I have 15 minus A. I mean 15A minus A squared is equal to 36. I'm going to add together, or bring together, everything over to one side, because I recognize that anything to the second degree right here, or if I have an equation with a variable raised to the second power, I immediately recognize that this is a quadratic equation. So a way to solve quadratic equations is to bring everything over to one side. So this will end up being A squared minus 15A plus 36 is equal to 0. So we can certainly try to figure out what what two numbers multiply to 36 and add to negative 15, but it looks like this is not something that's going to be factorable. So I'm going to resort to using the quadratic equation. Yes, quadratic equation is involved here. So if you recall, what was the quadratic equation? The quadratic equation looks something like this. So if I have, let's say, ax squared plus bx plus c is equal to 0, then the quadratic equation looks like this. So that's x. So that's what the root will equal to. So now I'm going to apply the quadratic equation with that quadratic right here. So I have a will equal to positive 15 plus or minus square root of 15 squared minus 4 times a, which is 1, times c, which is 36. All over 2 times 1. And I'm going to further reduce this. This is going to be 15 plus or minus square root 225 minus 144 all over 2. And we're in a home stretch. This is 15 plus or minus 225 minus 144. What is that? So really quickly, because I can't do mental math, minus 144. That is 81. Whoops. So I'm going to get 15 plus or minus 81, square root of 81, all over 2. And this then reduces to 15 plus or minus 9, all over 2. Well, you know what? This thing was factorable. OMG. So this turns out to be 24 over 2, or comma 15 minus 9, that is 6 over 2. So the two roots are 12 and 3. 12 and 3. Okay? So a happens to equal to 12 or 3. Now, why do we end up with two different answers here? Well, that's because the triangle can be drawn in two different ways. It could be drawn in this manner, or it could be drawn in this manner. And what do I mean by that? Well, it could be 12 and 3, or 3 and 12. And this is 6 here. Okay? So these are the two different ways that we can draw this. Okay. Would that make any difference between what A and B is? What B and C is? Not really, because as you can see, one triangle is really the reflection of the other. So both triangles are congruent. So we're really talking about the same kind of triangle. Okay? So let's figure out what B and C is. So for B, all right, if I have it drawn in this way, we're going to need to use the Pythagorean Theorem. So I know that 6 squared plus 3 squared is equal to B squared, right? So therefore, this is going to be 36 plus 9, which is 45, is equal to B squared, or B is equal to 3 square root of 5. And then over here, I can have 6 squared plus 12 squared is equal to C squared. So therefore, this is 36 plus 144 is equal to C squared. So therefore, this is going to turn into 180 is equal to C squared, where C is equal to, what is C equal to? So it's 36 times 5. So it's 6 radical 5. And there you have it. So those are the three lengths. So we're dealing with A could either equal to 3 or 12. Whoops. All right, thank you for watching.